This is Tech Math 2. We're in section 5-8, which is whatever we did in the rest of chapter 5, we're still doing it, section. So that's just the way it is. So solve and check. Oh, bummer, we have two things to do. Solve and check it. And we'll look at number 1 for a warm-up problem. X over 3 minus x over 6 is equal to 2. What I would do with a problem like this is get rid of the fractional part. Just multiply everything by 6. 2x minus x is equal to 12. X is equal to 12. X equals solution set 12. And so that would be the perfect answer. There's nothing wrong with that answer. That would be perfectly okay too. And now we're going to check our work. 12 over 3 minus 12 over 6 is supposed to be 2. And let's see, 4 minus 2 is 2. Check. So we solved it and we checked our work both. We just got lucky. That's all there is to it. Okay, number 3. 3m, 2m, 23 over 2. Well, I would do the same thing. I'd multiply everything by 20, and that gets rid of the denominator, and that would be cool. So I got 15m plus 8m is equal to 230. And this is 23. It is, really? Yeah. 23m is equal to 230. So I'd have m is equal to 10. I'd write m equals solution set 10. And that would be my perfect answer, but there's nothing wrong with that guy there either. And then I check my work, and I go 3 times 10 over 4 plus 2 times 10 over 5 is supposed to be 32, 23 over 2. So I got 30, and I got 20. And my common denominator is going to be 20, so I'm going to multiply top and bottom by 20, and 600 plus 400, 800. What's 5 times 3? 5 times 3 is 150. Good recovery there. And then 4 times 20 is 90. Divided by 20. 240 divided by 2. That's an 8. That's a 3. That's a 20. The 2's go away. 23 over 2. Check. All right. Now, probably what I would have done is just put the numbers in my calculator and gone 3 times 10 divided by 4 plus 2 times 10 divided by 5 minus 23 divided by 2, and it comes out 0. Therefore, I check. So that's probably what I do to check it. I just put it in my calculator and check it. All right. Number 12. X over 15, 1 over 3, x minus 3 over 5. And I do the same thing again. I get rid of the bottom, again, multiply by 15. X plus 5 is equal to 3x minus 9. 2x is equal to 14. X is equal to 2. X is equal to 7. X is equal to 7. And I'm done. Okay, so now I'll go back and check my work. 7 divided by 15 plus 1/3 minus 7 divided by 5 plus 3 divided by 5 equals 0. Now, this is something else. We'll do one more thing here. If I take my calculator and I go second function number solver, which is the sine, inverse sine key, and I were to enter x divided by 15 plus 1/3 is equal to quantity x minus 3, close parentheses, divided by 5, what would my calculator do? It would solve it how come it didn't give me 7? Stupid calculator. All right, I'll try it again. Numerical solve. All right, so I've got x times 15. You stupid calculator. Yeah, that's supposed to be a divide sign. X divided by 15 plus that. Okay, so now I've got it entered right. Okay, enter and solve. Solve for x. Oh, x is equal to 7. So the calculator does come up with x is equal to 7. And so there's no excuse getting any of those wrong ever again. Well, I guess we should do the problems with real things in them. So we'll do 19. Well, all right, we'll do 18. Anybody know what 18 is? Resistance is equal to resistivity times the length divided by the area. So it's the resistance of a wire or a bar of copper or whatever it is. And we want to solve for resistivity. So resistivity would be R A over L. Okay, 19. Current on the load. Voltage divided by the resistance plus the resistor of the load. Okay, so looks like we're in what is it called? Circuit analysis 1 again. Current of the load, voltage divided by resistance total. Okay. So I'll cross multiply current load R plus current load RL is equal to V. And then I'm trying to solve for R. So I'll go current load R, V minus I, L, I, RL, and final answer, voltage minus the current times the resistance divided by the current. Okay. Number 20 is a problem dealing with lenses. It's a lens problem. So you have a focal length and you have a distance to the object, distance to whatever. But we don't have to worry about that until physics 2. So we'll solve for R1 in number 21, because that looks like an electrical problem. So 1 over resistance total is, and they don't even have resistance total when I do there, R1 plus R2. And I'm supposed to be solving for R1. Right, so R1 equals 1 over R total minus 1 over R2. We'll do a vote. Is that okay to just leave it that way? Ben says it's okay, so it must be okay. But we could have gone and found a common denominator, inverted and multiplied, and all those other such things. But we'd entered that into our calculator that way, right? We just fit 1 over parentheses, whatever. Yeah. So I don't think there's any problem there. Okay, number 27 has to do with charge. Is voltage charge divided by current? Well, we can't do that problem. Voltage isn't charge divided by current, by resistance. V is equal to IR, right? So V is equal to IR, and the current is the change in charge, change in time. So, but it's not Q divided by R1. So those problems, 27 and 28, we can't solve because they are not physically correct. So we're going to skip them. That'll teach those guys and give us problems. Did we do 23? Oh, okay, we'll go back and do 23 because somebody assigned it as homework. 23. Y, x plus y divided by x. And it wants, wait a minute, I already have y is equal to something. Haven't I solved for y already? I guess not. So I've got x, y minus y is equal to x. I've got x minus 1 times y is equal to x. And I've got y is equal to x divided by x minus 1. Okay, so now I've got something. Instead of having something where the y on both sides of the equation, now I have something with only x's on one side and the y on the other side. And now my 8th grade math instructor would be happy that I did the problem right. Okay, we'll do number 30. Uh, 7, 2x. Now, do any of you guys like broken records? I mean, they're a very good thing, right? Broken records. So I'm going to do the same thing. I'm going to get rid of the denominator, right? Multiply both sides by 6x. All right, so at least we have 3. So I got a 21 minus 10x is equal to 6. All right, wow, that looks pretty good. Minus 10x is equal to minus 15. X is equal to 3 over 2. Now, we're going to go back up and put it back in my calculator again. I'm going to go second function, numerical solve, and I'm going to put 7 divided by, in parentheses, 2 times x, close parentheses, minus 5 divided by 3. Then I'm going to delete until I get to the equal sign. Then I have equal 1 divided by x. And then I'm going to get rid of everything else that was in my calculator and hit enter, and then I'm going to solve it, and I get 0.5. 0.5? 0.5? How can I have 0.5? 0.5 isn't 3 over 5. Stupid calculator. So I got 7 divided by 2x, that's right. Okay, well, I don't have divided by 3 on the 5. Okay, so I come over here, and I'm going to go insert divided by 3. So if I don't put the right problem in my calculator, then that's a different issue. And I got now I got 1.5. So my calculator's telling me the answer is 1.5. So now I'm happy. But if I can't, I mean, I should have looked at it before I hit enter and see whether I even bothered to enter the right problem, which it turns out that I did not. All right, well, that's beside the point. Okay, we'll look at 35. X plus 2, x minus 3, x plus 1, x minus 1. I think we'll just cross multiply. I think that's what we'll do. All right, so I've got x plus 2 times x minus 1 has to equal x minus 3 times x plus 1. All right, so x squared minus x plus 2x, plus x minus 2 is equal to x squared minus 2x minus 3. Okay, the x squareds go away. Don't have to worry about them. I can have 3x is equal to minus 1. X is equal to minus 1/3. And now we'll go back to the original problem and see if I can enter it in my computer without fat fingering a key. Okay, so I got parentheses, x plus 2, close parentheses, divided by parentheses, x minus 3, close parentheses, equals parentheses, x plus 1, close parentheses, divided by parentheses, x minus 1, close parentheses. Enter, solve it, solve it. Come on, I know you can do it. It's still thinking. No sign change error. Thank you very much, you stupid calculator, anyway. Now I can't, so what did I do? X plus 2, x minus 3, x plus 1, x minus, so I've got it entered right. We're going to give you one more chance to get this right. Nah, it's not going to do it. All right. So we have limitations in our calculator that we may or may not be able to deal with. Okay. So what do you think? One more problem? Number 44? What do you think? 44 or 43?
Or 44.
44? Do 44? All right. That looks like fun. Number 44. Look at that. I'm even going to do it in red. No, I don't think I'm going to do it in red. Okay. All right. Let's see. I don't know if I can even write it down right, let alone get it right. Yeah. There's a definite issue here. 2x squared, 5x plus 3, 3x minus 4, 2x minus 3, 2x plus 1, x minus 1. Okay, like I said, I'm a broken record. I'm going to do the same thing. I recognize that 2x minus 3 times 2x minus 1 is 2x squared minus 5x plus 3, right? So this is minus 2x minus 3x giving me 5. Yeah, it is. So if I multiply the whole thing by 2x squared minus 5x plus 3, then I'm going to get rid of the denominator. Okay, so I'm going to get 7x squared plus x minus 17 minus 3x minus 4 times x minus 1 is equal to 2x minus plus 1. 2x plus 1 times 2x minus 3. And that makes the problem so much easier. Okay, so I got 7x squared. I've got an x. I got a 17. I've got a minus 3x squared. I've got 3 and 4 is 7. It's a minus 7, but I got a minus sign there, so I'm going to get plus 7x. I got a 4 times 1 is a 4, so that's a positive. The minus sign makes it minus 4. And that's going to be equal to, I got 4x squared. I got minus 6 plus 2, so I got minus 4x. And then I'm going to have minus 3. Well, isn't that marvy? Just marvelous. I got 7x squared. I got minus 7x squared. That was convenient. I got 7, 8, bring that 4 over, 12x. 17, 21, minus 21 becomes a plus 21. This becomes an 18. X is going to be 18 over 12, which is what? 9 over 4. And I'm supposed to check my work. Luckily I have 9 more minutes. Alright, so if I'm going to check my work, how am I going to check my work and possibly get it right? Okay, so 7 times 9 over 4 squared plus 9 over 4 minus 17 divided by 2, 9 over 4 squared, 5 times 9 over 4 plus 3 minus 3 times 9 over 4 minus 4, 2, 9 over 4 minus 3 is supposed to be equal to, do I have enough room? 2, 9 over 4 plus 1, 9 over 4 minus 1. Yes, and I'm supposed to be able to do that and not make a mistake. Isn't that lovely? That is just so great, I tell you. All right, so we got 7 81s over 16 minus 9 over 4 minus 17. I don't even have a common denominator yet. Divided by 2 81s over 16 minus 45 over 4 plus 3. I got 27 over 4 minus 4 divided by 18 over 4 minus 3. At 18 over 4 plus 1, 5 over 4. I think breaking out the calculator a long time ago would have been a better idea than what I'm doing. Okay, so I got on top 7. Okay, so I got 7 times 81 divided by 16 minus 9 divided by 4 minus 17 equals. So I got 256 over 16 divided by. 2 times 81 divided by 16 minus 45 divided by 4 plus 3 equals. I have 15 over 8 minus 27 divided by 4 minus 4 11 over 4 18 divided by 4 minus 3 3 over 2 is equal to 18 divided by 4 plus 1. 11 over 2, 5 over 4. Okay, so we're going to invert and multiply. That's what I'm going to do. 256 over 16 times 8 over 15 minus 11 over 4 times 2 over 3 is equal to 11 over 2 times 5 over 4. If I would have done that right, that would have been really cool. 4 over 5. 4 over 5. Okay, so that goes into there, that goes in there. Okay, so I should get 22 over 5 on both sides of the equation. Okay, 256 divided by 16 times 8 divided by 15 minus 11 divided by 4 times 2 divided by 3. Boom. And I get 67 over 10. Doesn't that just piss you off? All right. So where's the mistake? How far up is it, I wonder? So I wrote that one. Did I write the problem down right? It would appear so. All right, so I've got that. I got this times that. I got that times that. I got that. X squared minus 7 becomes a plus 7, plus 4 becomes a minus 4. I got that. I've got plus 6 minus 2, that's right. That's right, so everything's fine. That goes over there, gets rid of it. 7, 8, 12. That looks good. 17, 21. 21 minus 3 is still 12. All right, so 21 minus 3 is 18, right? 21 minus 3 is 18. Okay, and 18 over 12 is still, what's half of 12? It is? That just piss you off. Anyway, Ben, how come you didn't catch that? So 3 over 2. So 3 over 2 is our new answer with all of 2 minutes left in the class.
Oh, we don't need to check it because that's right.
And what makes you think that's the case?
Because you just figured out the problem.
3 over 2 is, but if we don't check it, how do we know 3 over 2 is right?
Lucky guess.
Lucky guess, yeah, I guess so. Is this a 21? No, this isn't a 21. So, at least with 3 over 2, That makes the math easier, right? All right, so 3 over 2, 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 3 over 2. All right, luckily I got a big enough eraser. All right. 9. What's 9 times 7? 63? 63 over 4 minus 17. 9 times 2, 18 over 4 minus 15 over 2 plus 3. I got 9 over 2 minus 12. I got 6 over 2 minus 3. And I got 6 over 2 plus 2. And I got 3 over 2 minus 1. Did I run out of time yet? I'm just stalling if I run out of time. Oh, I'm out of time. I won't be able to check the whole thing. Oh, bummer.